In this lecture, we are going to discuss a few examples about the coverage area that we have discussed in the last class in our lectures. We have completely covered the coverage area, that how can we calculate the coverage area for for a given information. So for that we can completely solve this example, and then we can understand. The example is that find the coverage area for the cell, and this information is given: a cell of radius is 600 meter, base station and transmission, power of 20 dBm, a minimum received power requirement of minus 110 dBm. And the path loss model for this one is PRD is equals to PT ka D naught divided by D whole power gamma. So keep in mind that the for this type of example, the path loss model is given. So that is why you have to use this path loss model. Like in our previous examples, we have used the other path loss model where the P R was equals to PT GT GR and then lambda by D 4 pi D whole square. And the second was and in some other examples, so we have used another path loss model. So we, like you can see, the path loss model for that one is basically, if I wanna show you, so the path loss model was like in the classes we have used the path loss model are different from that one. So this was basically the path loss model. Okay. So PR was equals to PTGTGR and lambda by D square. Where lambda was free space gain. And the second thing is that the free space path loss basically equals to 20. If it is a free space, so that is uh, the inversion of the free space gain. So that is equals to 1 upon G of f of s. So that was 4 pi d upon lambda. And if we want to consider the distance d naught and the frequency as well, then this path loss model formula is again equals to this formula. Like path loss is equals to path loss which is dependent on the frequency, and then you are again multiplying with another factors which is d upon d naught and then whole square. So, but in our example, like in this example, the path loss model is equals to PRD is equals to PTK D naught upon D. But in our class, you can see the path loss model was different. So the path loss model was equals to PLD naught comma F plus 20 log D upon D naught. Okay, so that is why you don't need to confuse, or you don't need to confuse this path loss model with this example. So for this particular example, the path loss model is given with this equation. So you have to use this equation in order to calculate the coverage area. So if the path loss model is given to you like different free space path loss model, then you can use this equation. Then you can use this equation. But if the path loss model is given to you already, then you do not need to worry about that. You can use directly this equation and the value of gamma, because this is not a free space path loss model. So in that case, the value of gamma is given. So gamma is equal to 3.71, and the value of k is also given, minus 31.54 dB, and d naught is equals to 1, and shadowing standard deviation is equals to 3.65 dB. Okay, so everything is given. And we know that the formula of the coverage area is equals to Q of A minus exponential 2 minus 2 AB divided by B square, and Q of 2 minus AB divided by B, where A is equals to P minimum. So this is the minimum threshold value, and PR of R. Again, I am saying that this path loss model is given. Okay, so this path loss model is given in this example, which is this one. So you do not need to use this path loss model equation here. So this path loss model equation is something else, and this path loss model equation is something else. But for this particular equation, for this particular example, the path loss model is given in this format. So pt plus k plus 10 and then gamma log 10 d naught upon d. So which is like this one. So path loss model is that one. So here a was a parameter which is equal to p minimum threshold minus the received power depending on the value of the r divided by shadowing standard deviation, and b was equals to 10 gamma log 10 e, and then this e is equals to exponential and then bracket 1 divided by again standard deviation. So here in this equation p minimum is given, standard deviation is given, but you need to calculate this particular value. So how can you calculate this particular value? So the path loss model is given, so that was this one. So if you want to write this in term of dB, so you can like write in term of dB, so that is the product is always equal to you can open the product with the sum sign, with the addition sign. So pt plus k and then plus k 10 log. So this is linear, so that is why 10 and then this exponential. So this exponential, this one, and then log 10 and then d naught divided by d. Okay, use this equation. So here d naught is equals to 1, and you know log 10 of 1 is equals to 0. So again this is like a division ratio, and you know in logarithm if it is a division you can open it with the minus sign, like you can write it log 10 d naught minus log 10 d. So as I wrote in this format, so this one is like you can take this portion as a d, and you can open d like this, 10 multiplied by exponent multiplied by log 10 d naught minus log 10 d. So this d naught is equals to 0, and then this will multiply with the inside, and this negative sign is there. So this one is 10, so this one is 3.71, and d is 600. So if you insert all these value, you can see the value of the d is that one, 37.1 multiplied by 2.778, which is approximately equals to 103 dB. And we already know that the value of k is minus 31.4 dB. So you need to use all these values in this equation, and then you can easily calculate the mean received power. So mean received power is equals to 20 is given. So this was plus, but the value is in minus, so that is why it is minus. So this was plus, but the value is in minus, so that is why it is in minus. So if you like uh, explain, if you take the addition or subtraction of these results, then you will end up with this value minus 114.6 dBm. So you have already calculated all the unknown parameters. So you can use those unknown parameters in this equation B. So then you can calculate easily A. So A, this is P minimum was minus 110, and you have calculated the PR. So PR is, you can see it is minus. So there is a minus as well. So minus minus plus. So and the standard deviation is also given. So the value of A is, if you summarize this, then the value of A is equals to minus 1.26. Similarly, you can use the value in this equation like in C. So 10 and gamma is 3.71, and then you can write all these values, 10 into 3.71 log 10 and exponential 1. I usually use you can use your calculator, but I usually use Google. Like I wanna write log 10 and then exponential of 1, and then if you press enter, so you can see the answer is 0.434. So you can use that answer there. So it is 0.4341. Okay, so you can directly use this value here, and then divide it by 3.65. The answer is 4.41. So you calculate the unknown parameters for equation A and for equation B. Now you can easily calculate the value of this coverage area, the equation of A. So how can you calculate the value of A? So using all these values. So you can use all these values in this equation. So C is equals to value of A was 1.26 exponential 2 minus 2 multiplied by 1.26 multiplied by 4.41 and then divided by whole square, and then Q2 minus A multiplied by B divided by B. Okay. So you just enter all these values so you can see these results. So Q 1.26 exponential minus, again you can write this exponential minus 0.46 in Google. So you can write here, you can see. So if you write exponential here, it is so minus 0.46, and then you can enter. So you see the value is 0.631. Okay, so the value is 0.631. And then the other thing is that how can you calculate q? So q of minus, so if it is minus, so q is minus, you can write 1 minus q of 0.807. So for this you need q, table of q. So where is the table of q? So the q 0.807. So just get the table of q. So table of q is this one. So 0.807. So this is point 0.8, and then you need to go in this direction. So this is, so you see this value. So this is point 0.8, and then if you keep continue moving in this direction, so you can easily see 0.807. So this one is 0.7, so this one is 0.7, and this one is point 0.8. So that is why this where these two values combine, so you can see this one 0.1922. So that is 0.1922. So you can write the 0.1922 here and subtract 1 minus 0.1922. The answer is 0.8078. So if you multiply 0.807 with zero point 0.6, the answer is 0.509. And second, how can you calculate Q 1.26? Again, you can need to go to that table. So 1.26. So this is 6, and you know this is 1.2. So x is 1.2. So in this direction it is where is 6? So this is 6. So you see 1.26. So it means that this value is 0.1038. So you can use this 0.1038 here. So if you add them together, the answer is 0.61. So this was the coverage, so which is 60%. So it means that most of the area has not been covered. So that is why the answer is like the answer is not oh sorry, the minimum C power is not that good. You need to do something else so that you can receive the maximum signal strength. So like here, so you see it is 60%, which is not good. So the second question, the second example in this case was that, like if the received power, so what happens if the threshold value of the power, so if you change the threshold value of the power, which is, so the other thing was that if you change this minimum receive power to minus 120 dBm, then what happens? So where you need to do the changes. So our minimum receive power requirement, you have, if it is minus 120 dBm, then it means that you just need to do changes, uh, not here, not here, not here, only here. So you need to do the changes here in calculating the value of A. So where you can write here minus 120 rather than 110. So if you write minus 120, and then you will end up with the value of A. Everything else remains the same, and then you can see that the answer will be 0.988 dBm, so which is quite good. So like the 80% power, which is quite good. So I hope you understand this example very well. But if you still have a question, or if you still do not understand uh, any equations, like if you have any confusion with this example, you are most welcome. You can ask your question in the comment box, and I will try my best to answer the questions. Thank you for watching the video.